All right, folks, I'm not going to be here today, but you're still going to get a lesson because I have the power of technology. So I am going to start Chapter 6 by giving you notes over YouTube. So first thing I need you to do is grab an assignment sheet off the front table, or somebody pass them out, a practice packet, which should be right with the assignment sheets, and then you need a notebook or a sheet of paper to take notes on. Hopefully you guys grabbed a notebook over the weekend. Again, we're not doing the notes on the packets anymore. If you didn't grab a notebook, just grab a sheet of lined paper and you will have to add it into a notebook when you get one. But Chapter 6 is 6 sections, roots, powers, and logarithms. We start with roots and we will make our way to logarithms within the next week. So I really enjoy this chapter. Actually, pause this right now. If everybody doesn't have everything you need, go ahead and pause me here and get your assignment sheet, practice packet, and piece of notebook paper to write, or a notebook to write the notes in. Okay, first concept now, we'll launch right into it, is the idea of a root function. Okay, and it comes from this expression right here. X is an nth root of k if and only if x to the nth power equals k. Okay, so another way of looking about that is you can obviously take that backwards and say, well, if that's true, then if I take the nth root of k, it's got to equal x. Well, absolutely. Okay, so for example, if I have x squared equals 4, then obviously x is 2, or negative 2. We'll get into that in a second. I can square root both sides and say x equals 2. So going back the other way, we could say 2 squared equals 4. So that's the idea here between root functions. A couple quick examples. If x squared equals k, so if x squared equals k, then we can say that x is the square root, x is equal to the square root of k, easily taken care of by square rooting both sides, and hey, x equals the square root of k, something you guys have been doing for quite some time. So understanding this relationship. Another example, 6 is a fourth root of 1296, because, well, two things. 6 to the fourth power equals 1296, or once again, if I take the fourth root of 1296, it equals 6. So you've got to be able to understand this relationship between a power and a root function. On your calculator, if you want to take a root of some number, like suppose I wanted to take the fourth root of 1296, it's quite easy, but you have to put the root out front first. So essentially what I'm trying to say is if I were to plug this into my calculator, I would put a 4 in first, then I would hit the math button, and it's the fifth thing down. Okay, it looks like this, x root. Okay, your calculator will automatically know, hey, you want this 4 to go right in here for the x, and then you enter your number. It'll take the fourth root of 1296, and it should tell you 6. So go ahead and try that for a second. Make sure that you understand how to take any root, not just a square root or a cube root, but any root. Try doing the fourth root of 1296 in the calculator. Okay, so switching gears here just a little bit. You're going to be asked how many real nth roots does a number have. Okay, pretty straightforward. The answer is going to be 0, 1, or 2. If n is odd, so if you have an odd exponent, if you're taking a cube root or a fifth root or a seventh root, you're going to have one root regardless of what the value of k is. And basically what I mean by that is, let's say I have x to the third equals 729. I cube root both sides. You can do that in your calculator and you should get x equals 9. Well, 9 is the only answer, okay, because I have an odd exponent. Again, that means 9 times 9 times 9 equals 729, okay? If I had said, well, it could also be negative 9, because we know with square roots it can be positive or negative. It can't be negative 9 because if I have a negative times a negative, it results in a negative, and I have a positive 729. So for that reason, there is only one solution if you are taking an odd root of something. Now suppose I'm taking an even root. If my root is, my n is even, well, as long as you're taking an even root of a positive number, for example, x to the fourth equals equals 256, and I want to figure out, okay, how many solutions do I have? Well, I have a positive k, I have an even n, so there's going to be two solutions. Reason is, when I take the fourth root, that should be a 4. When I take the fourth root of 256, I get x equals 4 from my calculator. But I have to be smart enough to know it could also be negative 4. So your answer is positive or negative, or positive or negative 4. And the reason is 4 times 4 times 4 times 4 is 256. But negative 4 times negative 4 times negative 4 times negative 4 is also positive 256. So that's your reason there. You have one root if you're taking the root of 0. There's 1, and that's going to be 0. And obviously there's 0 real roots if you're taking the root of a negative number, because that would give you an imaginary number, which we will get into later, but not right now. Okay, this next part and last part is going to be tough to do without being there to show you guys, but hopefully you have your own graphing calculators and you could check this out. Inverse operations, the nth power and the nth root. Okay, so what I'm talking about here, if I have f of x equals x to the nth, and say g of x equals x to the 1 over n power, with this domain, positive domain, and an n value of greater than or equal to 2, they're inverse functions. Okay, if n's not greater than or equal to 2, so say n is 1, then these are going to be the same functions, because 1 divided by 1 is obviously the same as 1, so they'll be identical. And if n is 0, then we have undefined up here, and that's bad, so we're not going to deal with that. So it's got to be an n value greater than 2. So inverse functions, for example, f of x equals x to the third, and f of x equals x to the 1/3. Their graphs are going to be inverses. And based on what you already learned about inverse functions, they're going to be reflections over the line y equals x and all the other things. And you can graph those and take. Keep in mind, they will also have points in common. They will share 0, 0, and they will share 1, 1. So go ahead and try for a minute, and you can pause me on here, and try graphing y equals x to the 5th and y equals x to the 1/5, and hopefully you'll see that y equals x to the 5th. Now we only care about the positive domain. Okay, y equals x to the 5th is going to look something like this, go up pretty rapidly, whereas y equals x to the 1/5 is going to look something like that. Okay, and again, they are reflections over the line, y equals x, as all inverses are. Two properties in this section, this will complete it for notes. One of them is a power postulate. Okay, and this is something that you're just going to have to put in your back pocket and know. If you have a variable to a power, parentheses, another power outside, you multiply those exponents. So for example, if I have x to the 5th to the second power, that becomes x to the 10th. Okay? And people say, well, sometimes we only add exponents sometimes. If your exponents have their own base, for example, if we had x to the 5th times x squared, in that case, since they both have their own base, and by base I mean the x, in that case, this would be x to the 7th. And this is something you learn in Algebra 1. You add the exponents there. But in the case of a power to a power postulate, where you have an exponent 5 raised to another exponent 2, you multiply and you get x to the 10th. So be able to keep this situation in your mind and separate it from this situation, because that's important to know the difference. In addition, last postulate, which doesn't have a name, so I named it the extremely important postulate. I use this one quite often. If you want to take the root of something, it's the same thing as doing 1 over, an exponent of 1 over. So for example, if I want to take the square root of 16, I know that's 4. And again, square root, there's a 2 there, but for whatever reason we don't write it. Well, that's the same thing as doing 16 to the 1/2 power. And so a lot of times it's easier to just do, if you get an answer on your calculator and you want to square root it, rather than punching in second square root and then the number again, you just can hit caret 0.5 and it'll give you the same answer. 16 to the 1/4 or 1/2 power is also equal to 4. Okay, so that's the extremely important postulate. Taking the 9th root of x is equivalent to doing x to the 1/9 power. Okay? Okay, on to the examples. So pause this if you need to get your examples out for a minute. Everybody get their examples out. I'm just going to walk through these, and then you guys will be all set to work on your homework. For number 1, show that 1.5 is a cube root of 3.375. That's pretty easy. All we're going to do is take 1.5 and multiply it times 1.5 3 times. And that shows that 3.375 is 1.5 to the 3rd power. Okay, so essentially 1.5 to the 3rd equals 3.375. Show that negative 1.5 is not a cube root. Well, same thing. If I do negative 1.5 times negative 1.5, I get a positive. But then if I multiply by negative 1.5 again, I get negative 3.375, which is clearly not equal to 3.375 due to the negative. So that shows that. For number 2, if we want to evaluate some roots, again, this is the same thing, and of course, you have your calculator. You could do 1/8 to the 1/3 power. Please bear in mind that you do put that in parentheses. But essentially what I'm doing, if I have the 1/3 power, is I'm taking the cube root of 1 and I'm dividing it by the cube root of 8. Cube root of 1 is 1. Cube root of 8 is 2. So the answer to 2a is 1/2. If I want to take the 4th root of 81, I'm basically asking myself, well, what times itself 4 times would equal 81? Or this equals 81 to the 1/4 power, essentially. And 84th to the 1/4 power, or the cube root of 81, equals 3. Again, quickly done using your graphing calculator. Based on the last page of notes, you should recognize number 3. It says graph the functions f of x equals x to the 6th, and a g of x is x to the 1/6. It tells you what window to use, and it tells you the scale, and it tells you what window to use for domain and range, and the scale. And says on what domain are f and g inverses. And I'm not going to graph it, obviously, because I can't project my calculator on here. But it'll look something of this nature, hopefully. That's very bad. Just ignore that I ever did that. On what domain are f and g inverses? Well, if you look back, we only are going to do this on what domain? And the domain is when x is greater than or equal to 0. So only the positive values of the x values, including 0. Okay, we're going to skip number 4 right now. That pulls back in some geometry, and without me there, we're not going to deal with that. So that concludes your notes and your practice. Go ahead and grab your books or grab a book and work through the assignment on the assignment sheet. Should be able to get that thing done in class. And if you don't understand how to do something, don't be afraid to read the section because it will help you. Hope you have a good day. We'll see you tomorrow.